Certainly these two men, above all others, Steinmetz and Langmuir, put Schenectady on the map as the city that lights the world, to go with hauling the world. And they did it in a way, there's an old saying that if you shoot the electrician, the lights will go out, but you get another electrician and fix them. If you shoot the scientists and engineers, it'll take 30 years for the lights to go out, but then you'll never get them on again. They were these people who provided this foundation for the electricity that we know of today. It's not that they went around and wired your houses, but they provided the know-how for the people who did and for the many applications that follow. So let me start with one of the, start by turning on the power. One of the two pictures we have of Steinmetz and Langmuir together. Now when I show this picture, everyone, and I heard again, whispers Steinmetz, Steinmetz. No one sees poor Langmuir here, who's standing off to the left in the hat. Also, not everyone sees Albert Einstein to Steinmetz's right, David Sarnoff. This is a real gallery of the greats of the electrical industry. They're gathered at the opening of a radio station in New Jersey in 1922, not too long before Steinmetz's death. Now, this picture serves as a good introduction to these two men because General Electric publicists did an interesting thing with this picture. They said, well, this is a kind of messy looking picture. Everyone's wearing hats. We want to focus in on the great contributions of somebody and the importance of one person. So they took this picture, and again, this was long before my time, cut out the picture of Steinmetz and Einstein, pasted it against a background, and distributed it as a picture of these two great geniuses going out and communing about the theory of relativity. This, Herb was a little too kind in comparing my work to Shakespeare. It's more compared to this type of thing, of a slight manipulation of the public mind. I'm really a public relations person who works with photographs as well as writing. And the image of Steinmetz was created to such a degree that it put almost everyone else, even to some extent Langmuir, into eclipse. So really we want to get back beyond this image, beyond the manipulation, and ask the question, what did these men really do? And I find it interesting that when I host a lot of visitors out at the GE R&D Center, that if you get someone from the United States or Europe, they know Steinmetz. But you get someone from anywhere in the world, Japan, Korea, India, you mention the name Langmuir immediately. They don't know him as a man as they knew Steinmetz. They don't know cigars, they don't know Hunchback, they don't know socialist, they don't know the other things, the personal things. But with Langmuir, they know Langmuir isotherm, Langmuir heterogeneous catalysis, the Langmuir plasma experiments, the scientific side. So men remembered in two very different ways. Steinmetz as a human being who nobody's quite sure what he did in science, Langmuir as a scientist who nobody's quite sure what kind of a person he was. So let's look a little into the dimension of them. Steinmetz really comes first. The two men were not contemporaries. Steinmetz was a generation earlier, born in the 1860s. And you ask, what did Steinmetz really do? And you can find a lot of complicated pages like this. I'm not going to try and explain this, but again, it illustrates another important point. I've mentioned that he wasn't really the pure scientist who communed with Einstein in the way that the GE publicity tried to represent. He wasn't the pure inventor either, like his contemporary Thomas Edison. I show this page because about 10 years ago, the people in Washington at the Patent Office, they have a thing called the Inventors Hall of Fame. And they called up to GE one day. As a matter of fact, I was the one who answered it just because I happened to be in charge of that particular part of the public relations at the R&D Center that day. And they said, we've elected Steinmetz to the Inventors Hall of Fame. Now will you please tell us, what did he invent? Which was kind of an odd way of going about it, but that's really the way people see Steinmetz. They know he was a great man, but they don't know quite what he invented. This is one of the things he invented. It's a kind of a circuit for recharging batteries on electric cars. Electric cars didn't really make it big, and this was not too successful. He invented a street light that was in place in Schenectady for many years, but that wasn't really the only or even necessarily the best type of street light. Steinmetz was really not at his best as an inventor or as a scientist. Well, then what was so great about the man? Well, this picture gets a little closer to it. You can see back on the blackboard some complicated mathematical drawings, but the point of this picture is Steinmetz in the classroom. Steinmetz was first and foremost an educator, a teacher. It wasn't so much that he had so many original ideas. He certainly did have original ideas that were important, but it was his ability to communicate these ideas to others, and even when he didn't communicate these ideas to others, he infected them with the excitement of science and technology. I hope the person I overheard won't mind me saying this, but I heard, just as people were coming in, I overheard someone saying, Steinmetz gave a lecture on relativity, and people afterwards, they came out and said, oh, this is clear as a bell, I understand it perfectly. They woke up the next morning, they didn't remember, what is it? What did he say? But they remembered the excitement and the enthusiasm he conveyed. Well, the same thing, a very important inventor, a man named Black, who invented a thing called the negative feedback circuit, which is crucial to radio. He was inspired to make his invention because he went to a lecture by Steinmetz. Steinmetz was up there scrawling all those mathematical formulas on the board, getting excited, waving his cigar, infecting him with the enthusiasm. Mr. Black didn't use any particular ideas of Steinmetz's invention, but he always credited him with giving him the idea that you could understand things in terms of mathematics. You could understand electricity, electronics in terms of mathematics. So that was his real contribution, not merely in a lecture hall, but also with small groups of people where he was at his best. The story that best illustrates this is a man named Doherty, who was a GE engineer, later president of Carnegie Tech, now Carnegie Mellon University. He used to say, well, the first time I'd come to Steinmetz, I'd bring him a problem, and he'd help me solve the problem. The second time I come to Steinmetz, he'd say, wait, let's sit down for a minute. Why don't you tell me a little more about the problem? And he got me to work my way through the problem. The third time, Doherty says, I didn't go to Steinmetz. I sat in my room and said, how would Steinmetz attack this problem? And I attacked it and did it myself. And he said, then I realized what Steinmetz was really getting at. He didn't want to keep teaching people. He wanted to teach people to become independent problem solvers. Here he's with his fraternity brothers. I believe it was the, I can't remember the name of the Phi Gamma Delta fraternity, I believe at Union, which he became an honorary member. So that was the man he became. How did he become this educator, this man who inspired others? Starting out in 1865, there's a fascinating parallel in his life with just what's going on in East Germany, indeed, just yesterday with the election. He grew up in what was then part of East Germany, now part of Poland. And in that time there was a dictatorship, not a communist dictatorship, but rather a dictatorship of the right wing under a man named Otto von Bismarck. Well, Steinmetz went to college and majored in philosophy, as they called it, although really he was in mathematics, which was then part of the philosophy curriculum. And he also, his minor, not in the academic side, but in his life, was the study of socialism. He got fascinated with socialism. So just as he was finishing his work that would qualify him as a doctor in mathematics and enable him to become a teacher in Germany, he was also editing a socialist newspaper. And his real aim was not socialism in the sense of government ownership of properties, but rather freedom of expression, really what we call social democracy today, or the social democrats, the idea of combining freedom of expression and individual freedom with more sharing and cooperative efforts in part of society. Well, this was not in favor with Bismarck, the dictator of Germany, and in fact there was a law against organizing in certain ways as socialists. Steinmetz and his friends had the bad judgment that not only organize a little party, but they had a picture taken of themselves that they allowed the photographer to put on display in his window as a demonstration of this photographer's skill at group photographs. This was not a very good idea because the policeman came along, wrote down all the names, and started going after the various people. Steinmetz was regarded as one of the more harmless of the group, so he really lasted longer editing the newspaper. But finally, he too saw that he was under suspicion, and he headed for the border for Switzerland and enrolled in an engineering school. His only formal engineering courses were taken in Switzerland. You could really, without exaggeration, call him a college dropout. He never finished a formal degree. He took a few courses at the State Technical Institute of Switzerland and then decided that obviously you weren't going to make much of a career in Switzerland if you weren't a Swiss citizen. It was better to go to the land of opportunity, the United States. He went with his friend Mr. Emerson across the ocean. I'm sure many of you are familiar with the story of how they arrived at the United States. Steinmetz had a cold. He was when the customs inspector asked, do you speak English? He said, a few, which kind of gave away that he wasn't real fluent in the new language. And do you have any money? No, or $5, I can't remember which, but certainly no substantial amount of money, at least according to legend. And again, these legends are very hard to track down. The customs inspector was about to turn him back as an undesirable alien because, again, born with a congenital hunchback of man, very unattractive looking man, looked like the newspaper cartoon of an anarchist, and here he was as a political radical as well. But his friend Emerson stood up for him, said, now, Emerson was a tall, handsome guy, any of the brains of Steinmetz, although no idiot either, but he looked much more respectable, said to the customs inspector, this guy Steinmetz is okay, and in he came. So the United States narrowly avoided one of the greatest mistakes it could have made in immigration history there and let him in. And within a very short time, he'd shown that the things which the customs inspector seen were really completely irrelevant to his genius. He may indeed have had no money in his pocket, but he had a letter of introduction to this man. And this was a man named Rudolf Eickemeyer, who had a plant in Yonkers, New York. And Eickemeyer was another interesting character who one could give an entire lecture on. He had been part of an earlier German free speech and liberty movement in 1848, and that's the one, incidentally, which the journalists today most closely compare the current movement to for freedom. He had fled Germany, come to the United States, set up a factory to make hats and been fairly successful. Then the Civil War had come along, and he'd figured out how to turn his factory into a revolver-making factory and was wildly successful, made a lot of money. After the Civil War, he went back to hat manufacturing, but he was sufficiently wealthy that he could afford to do whatever he wanted. He decided to get into this new field of electricity, and here he is just starting to think about perfecting some electric motors which he'd invented. And when this man, completely uninvited, knocks on the door with a background in mathematics, some postgraduate or at least pre-graduate work in engineering in Switzerland, and said, do you need some help in your factory? He was delighted. He said, come right in, sit down. And immediately Eickemeyer made Steinmetz his assistant. Well, again, GE doesn't like to admit this too publicly, but Steinmetz's really greatest achievements were done in this small entrepreneurial setting of the Eickemeyer factory in Yonkers. The two men worked together very closely on what was called the law of hysteresis of electric motors, which is probably, from a purely technical point of view, Steinmetz's greatest contribution. It was a way of making, selecting the magnetic materials for electric motors and transformers so they would run more efficiently, save money for people who are buying electricity. A complicated technical area, but easy to understand in terms of its value for making new electrical systems possible, particularly of the new kind called alternating current, which was more difficult than Edison's kind of direct current. So here the factory of Eickemeyer in Osterheld got to be at least a moderately successful little electric plant, successful enough to draw the attention of the big giant up in Schenectady, Edison General Electric, and another company over in Lynn, Massachusetts called the Thomson-Houston Company. And it was actually the Thomson-Houston Company that came down to Yonkers and started making noises about buying this company out. Everybody thinks that this new idea of mergers and acquisitions and unfriendly takeovers was invented by T. Boone Pickens and other people in the 60s, 70s, or 80s of our century. Actually, it was quite familiar to the early electrical industry. The way the company that became General Electric operated was by running around and buying up everybody good in the industry in the 1880s and 1890s. However, they were a little different than the kind of buyouts we have today. The first thing today after we have a buyout is what they call a rationalization, where they fire everybody who they can see, and everyone good who isn't fired quits because they're scared by the firing of the other people. But the companies at that time were very smart. They quickly went and saw the smartest technical contributors to these little companies and made sure they signed them on. So the Thomson-Houston people, soon to become the GE people, Edwin W. Rice and Elihu Thomson, came to this young man Steinmetz and said, we want you. What do you need to come with us? And made sure that he stayed with the new company. At this time, Steinmetz was developing some new ideas of mathematics of electrical circuits, which nobody probably in the whole industry understood at that time, but it was clear that this was a man who was doing something important, so they let him continue to work on it. Well, after some unhappiness in Lynn, Massachusetts, at the home of this Thomson-Houston Company, where there weren't any Germans and there weren't any socialists and there weren't anyone that Steinmetz could talk to, he found his way up to Schenectady, New York, where there were plenty of both. He put his socialism on hold temporarily now to prove himself as an engineer, became a little conservative, stuck to his office, and really proved the value of this idea that you could take mathematics and apply it to electrical circuits. So answering two of those questions, how did Steinmetz get to be the Steinmetz, the genius we know of today? It was really this dedication to mathematics, yet the being forced because of his political beliefs not to be able to be a pure mathematician. He would have been quite happy to spend his life as a pure mathematician. That, combined with the enlightened policies of this new electrical industry, who understood that when you buy out other companies, the most valuable asset of those companies are the people, the leaders. There were about a dozen of them, including Steinmetz, who GE bought up, who became the nucleus of their workforce later. People like W. L.R. Emmett and James Wood and the other giants of the early electrical industry were acquired in the same way as Steinmetz. And they were given a pretty free hand. It's a myth that Steinmetz was just handed a checkbook and said, we're not going to give you a salary, just spend all the money you want. That's not true. He was paid a salary, but he was given a free hand to do a lot of what he wanted in this plant. So the thing to emphasize about this Edison machine works was that maybe Thomas Edison, when he moved to Schenectady, thought, well, I'll just set up a factory up in the sticks where people don't understand about unions and I can manufacture things. But they soon realized that it had to be more than a factory of machines. It had to be a factory of brilliant people, because nobody quite knew what this electrical industry was, and it took brilliant people to figure out what this industry was. So that's what they really needed Steinmetz for. Steinmetz, the way he operated was, again, there's myth and there's truth, but I think in this case there's a reasonable amount of truth mixed in with the myth, that he had an unbelievable brain, much like you might say, I don't know, somewhere between a personal computer and a Sun workstation of today, where he could visualize problems in 2 or 3 dimensions, work them out in his head, visualize the solutions of these mathematical problems of electricity, do it floating out on the Mohawk River in his canoe without the need of any kind of calculating assistance, and get pretty good answers, which would then be checked by others and found indeed maybe wrong in a few decimal places or a need for specific calculations, but really got to the basis of the problem. He didn't really need the canoe, actually, as long as his cigar stayed lit, he could do it on the river. And again, it wasn't so much that he would solve problems for GE. It was that he would find the methods of problem solving, the general methods of what happens when there's a sudden voltage surge on an electrical line. How does that change over time? When you're trying to hook up many lines in parallel to increase the size of these alternating systems. He'd find the general methods and then teach it to others who would apply them to the specific cases. So again, it's hard to see his hand in any specific great invention or single great development, but his methods are the foundation of all of them. And I think the best legacy of all this, I was down at when GE still had the large motor and generator department in Schenectady. I was down there with a historian from Cornell, and Ron Klein, as some of you may have met, is writing a biography of Steinmetz and engineer Ed Owen. And we were talking to one of the guys sitting there at his workstation, and I think either Ed or Ron said to him, are those Steinmetz's equations you're using in your computer program? And the guy thought for a minute and says, yeah, you know, I guess they are. And I was trying to imagine how delighted Steinmetz would be. Steinmetz had his own unique ideas about religion. He toyed with Unitarianism and other religions. But I think the kind of immortality that would have most appealed to him with this idea that, first of all, that the fruit of his brain was actually immortalized in a computer program that go on forever, but also that it wasn't just his ideas, but it was a collective achievement of many people who had developed these equations that were still being used for motors. So this idea of collective electronic immortality, I think, would have really appealed to him, because that's really what his career was all about, laying the foundations of ideas that others could go on using forever. Well, Steinmetz had some other interests, too, in addition to his technical. We like to say this idea of genetic engineering and cloning isn't so new. Steinmetz was doing it 80 years ago. But the truth is, unfortunately, if he could have made 2 Steinmetzes, that would have been a great contribution. But unfortunately, all he really did was trick photography. My dad has pictures like this, too. It's not that unusual, but you can move. And anyway, he loved practical jokes and trick photography. He also, though, in with his practical jokes and his humor, there was usually a serious side, something where he saw something about the future, even in with the jokes. And this illustration suggests both of those ideas at once. This is the Mohawk Aerial Navigation Society's glider, and it has 2 sides to it. First, there's a perfectly truthful side that in 1895, at a time when most people thought the idea of flying was kind of crazy, Steinmetz and a group of other engineers in Schenectady founded a group to see if they could first make gliders and then fly the gliders and then perhaps maybe powered flight as well. Well, that's the serious side. The dishonest or unserious side is they never did get the glider off the ground, so they resorted to trick photography to get this picture made. It was too heavy to fly. And again, I could stand corrected by some of the other experts, but as I understand it, they never did fly and they finally gave up. But again, he had seen this glimpse into the future, and sure enough, a few years later, the Wright brothers, in an approach not all that different, did take the next steps. Steinmetz and Edison, people always ask this question, how did they get along? They're so different, Edison, the experimenter, Steinmetz, the theorist. Well, they had a lot of mutual respect for each other, but at GE we have to admit that even these two giants didn't always see eye to eye. And this is our fake trick photography. Myself and a guy named Tom Appel, who's the artist behind this, did this picture. And again, it's a fraud to illustrate a serious point, which is that Edison used to say, you've got to keep coming up with something that's useful. You don't want to be like those old German scientists who, as long as they get their black bread and beer, are content to spend their whole life studying the fuzz on a bee. That was his view of German science. Well, Steinmetz was kind of one of these old German scientists. He didn't take that too kindly. His view was a little different. Now, they never fought this out either physically or even in a debate, but this was the issue, I think, before the electrical industry. Steinmetz was saying, okay, that was fine for the 1860s and 1870s. You could invent by trial and error, by using the ideas of others. And again, it wasn't a question of Edison only doing trial and error. He used other people's scientific ideas, but he didn't do science himself. Steinmetz said, in the 20th century, now we're getting into the 1890s toward 1900, in the 20th century, if you want to be smart enough to make inventions, you have to do some of the underlying science, so that it's just your price of admission to be smart enough to make the inventions. Well, he put his reputation behind this because he went to the president of GE, well, first to the executive vice president, Edwin Rice, and then to the president, Charles Coffin, and said GE should do something that no other company in 1900 in the world had done, which was to set up a laboratory devoted to real scientific research, where you do science in industry and you publish the results. There were laboratories in Germany that did science in industry, but they're very secretive. There were laboratories in America that were fairly open, but they didn't do science. This was the first combination of a real university-type science laboratory with an invention factory all in one laboratory. And that, of course, was the GE Research Laboratory, now the GE R&D Center. Originally, right across down the street here, across Erie Boulevard, where the Burger King is, was in a little barn behind Steinmetz's house, and now at the huge site out at the Knolls, holding some 1,800 people. This is the barn as it looked before Burger King. And lasted only a short time before it burned down, and they moved to the GE plant and then out to the Knolls. And this is the initial group that Steinmetz gathered together. In the middle, a man, John T.H. Dempster, Steinmetz's laboratory assistant, who, as Steinmetz used to say, was so versatile that you'd see him knitting a scarf one day and playing the trombone the next. I'm not sure what that contributed to science, but at least he knew how to do a lot of things. On the right, much more significant, Dr. Willis R. Whitney, who Steinmetz interviewed for the job of research director and hired, and went to work with in the barn as the first director of GE Research. So this was one of Steinmetz's greatest contributions, this new conception of industrial research. The laboratory very quickly grew from those 3 people, this is about 1908, to about 30 or 40 people. You'll see in this picture, incidentally, the 2 women, one of them